Alright, hello, Gabe here, and I am here to explain to you making game development. This is kind of my introduction video. In order to make games, it's an elephant in the room that no one really wants to talk about, but you're going to need to know some of the fundamentals of programming. You can't make a game without programming. I mean, you can, there's WYSIWYGs out there, and I started off with WYSIWYGs, and there's nothing really wrong with that, but if you want to really make good games and you want to get things to users and stuff like that, it's probably best that you begin learning some programming languages at some period of time, and I'm here to teach you that right off the bat before we even start touching any game design concepts themselves. Without further ado, I am using the Unity engine. It uses MonoDevelop, which is based off of Xamarin Studios, but that links up with Unity and all that good stuff. And Unity runs its syntax off of C#, so that is the programming language I'm going to start off teaching to you. C# is very has a lot in common, I should say, with Java, and then we can build our own engine in Java using the standard Java library. Then maybe we can get in the lightweight Java library, and then eventually into C++ development. That is the concept for the game design field here. So let's start off with the fundamentals, right? So in C#, everything has to be contained inside of a class. I mean, not everything, but for the most part, most of the things you're going to be doing inside of Unity, at least, is going to be contained inside of a class, which will spread that concept a little and stretch it for a little further afterwards, after we really start getting into things. But for now, just make sure that everything stays contained inside of this class, right? And whenever I say contained inside of something, notice that there are these brackets, right? So there's one bracket here, and you see how that other one highlights there? That means that everything inside of here is contained inside of this class, right? So then everything inside of these brackets is contained inside of start, and everything inside of these brackets is contained inside of update. Really fundamental, basic understanding of brackets, but the brackets aren't important right now. What's important right now is to understand that there are three main things inside of every programming language. It does not matter what language it is that you are using. It corresponds in every single language, pretty much. There's a few languages, give or take, that it doesn't, but as far as game programming is concerned, there's only three things, right? And those are variables, methods, and then piping. Piping we'll get into a little later, but methods and variables we can jump right into right now, right? So C# itself is what we call a typed language, right? So that means whenever I declare a variable, I have to tell the computer what type of variable it is I am making, right? So let's do a fundamental variable here, right? Int stands for integer, right? A number, right? So then I can just name it, call it A, and boom, now we have a variable A. See how it immediately became italicized right there? It's really simple. All this is telling the computer is the computer reads this script from top to bottom, from left to right, line by line, right? So then it goes through and it reads and it says, okay, this is an integer, there's about to be an integer after this, and then it's like, oh, it's called A. A is its name, and it doesn't line up with anything else, so okay, there's a new integer called A. Is there anything else to do? Hits the semicolon, and the semicolon tells it needs to stop. The semicolon tells it that's the end of this line, that's the end of this phrase or process unit right here. Stop, move on to the next thing, right? So by default, the integer A is going to be set to 0, right? And integers, of course, if you don't know already, are whole numbers, right? So 0, 1, 5, 6, but you can't do fractions or decimals. It's always something whole, positive or negative, right? So whenever you declare an integer, it automatically starts off as 0, right? Integers don't become null or anything like that. That's just 0, right? So then if I come through and I do something like this, now I've set the integer to be equal to 2, right? And not only is it equal to 2, the better way to look at this is that I'm saying there's an integer, an object called A, and it is equal to whatever is on this side before this semicolon, right? So if you keep that in mind, I can actually do something like this. I can say integer b is equal to a, right? Sorry, because it's autocorrect, it's messing around, but notice what it's now done. It's created an integer a, which is equal to 2, and then it says b is equal to a, right? But it's not saying that b is equal to the object a itself. It's just saying b is equal to whatever value a contains, right? And that's very important to remember, that it's going to correspond to the value, not correspond to the object itself, which that gets more complex the higher level languages that you go to. C++, pointers, that's very important, but just remember that it looks at the value at that point and not the object itself necessarily, right? So with that being said, we can move on into operators, right? So I don't want to just have to set it equal to something, right? Because what if I'm trying to set it to be a little bit higher than a, for an instance? I don't want to say a something something. Well, there's actually some operands to do that, right? So instead of that, I can cut this out, just say b, for instance, and then say b is equal to no, let's just say b++ for now, right? And all that does is it takes b and it adds to it. It adds 1 to it. That's what the b++ operands mean. It's just like you have plus plus, you have minus minus, and then it subtracts 2 from it. Simple, right? But you also have other operands using the equal sign. So instead of plus plus, I can say plus equals 1, right? And that does the same thing, except I can now do other operands like plus equals 4, plus equals 6, plus equals whatever, right? But I can also, yet again, throw in that variable, and now it is going to be b plus a. It's going to add whatever the value is at a to b. Pretty fun, pretty straightforward. But let's talk more about these types, right? Because there are multiple types. We have integer types, which returns a number. On the note of numbers, we have float types, which a float is just like an integer, except it can also be in between. It can literally float in between integers, right? So if I have 1 and 2 and I start off equal to 1, then I can now float in between 1 and 2. It's pretty straightforward. I can set C, unlike I set A, I can set that to be 1.34567 or something like that, right? But it's a float here, and I have to put F, right, to follow it, right? Because if I just put this, if I just put this without the F, that is what we call a double. And then a double is a decimal. So, oops, my bad. All right, so the decimal, if it's a double, it does not have to contain that F afterwards. It automatically processes that information properly, right? There's no needed additives or anything like that. But what's important to remember about these types is I cannot set objects in between types, right? So you remember how I said b is equal to a, right? Well, I could do that because b and a were both integers. But now what happens if I try and do b and c is that the types won't line up, and the computer can't process this information without converting it over into a float, right? But we have other processes, right? So we have other types. We also have booleans, which a boolean is pretty straightforward. It's either true or false, right? It's either off or on, and by default every boolean starts off equal to false, and then I can set it equal to true, and then bada boom bada bing. Now there is an operator for booleans that I find extremely useful that you only really can do with booleans, and it goes a little something like this. I can set e equal to the opposite of e, right? That's all that little simple means right here, is that I'm taking whatever this value is and I'm flipping it over. And it's basically like a trigger that allows me to flip-flop, disable, and enable objects very quickly without having to write a ridiculous amount of code. It's really cool and just something specific to Booleans. Yes, that's for the most part all we really want to go over for right now. Oh yeah, one more thing. You have strings, right? And a string is just a set of characters, so to say. So a string doesn't have to be numbers, it doesn't have to be true or false. It can be anything that you can type on a keyboard, right? So I can just come in here and type anything, and that is a logical statement for a string, right? But notice something about the string. The string values have to be contained within these little parameter marks right there. Between those tallies or parentheses, it has to be contained inside of there in order for it to process, oh, this is a char set. This is going to be a set of characters. And that's all a string is. It is a string of characters. Fairly simple. Now, what's cool about type languages and what's cool about C# and being able to put a type right here in the first place is I can communicate between languages, right? So let's go back to this class, right? I have this public class called basics, right? So everything in here is in basics, right? But I can actually make an object called basics, right? A variable can be of the type basics. So I can come down here and make a new variable called basics. Oops. Basics. Base. Oops, I can't use that. Right? And then I can also do new fun things with that, right? So I can now do basic dot b plus plus. So what is it that I just did, right? I made a new object. There is an object here, and it is of the type basics, right? And since all of this is contained inside of this basic class, all of this is going to be contained inside of this object here called basic, right? So then I just referenced that and then did an operator plus plus of it. So I went into this new object basic, found the variable b, and then added one onto it. Pretty fun, pretty simple, right? But we can take it a step further, right? So in a game engine, we are going to have game objects and a bunch of pre-made objects that I then create. Then I then instantiate and create instances of that object, and then I can reuse it wherever in the world I want and however in the world I want, and I can manipulate specifics and variables about the object, right? So there's a bunch of pre-made classes inside of Unity itself that I can use through the game engine, right? So the first useful one that you will see everywhere is a vector2. Right? So what is a vector? A vector is just a set of floats. It is just a bunch of individual floats. So whenever you see vector2, vector5, vector3, that just means that there's 2 floats, there's 3 floats, there's 5 floats. In this case, vector2 means that there is 2 floats contained inside of this vector. Right, so if I go into V here, we should see that V has an X. Oops, V has an X, and V also has a Y. Pretty simple. These declarations do nothing. They're pretty blatant and pretty obvious, but they prove the point that I can now access that. And all that means is that just how there is a float inside of here called Z, inside of vector objects, and inside of this class vector2, there is an X float and there is a Y float. Pretty simple. So let's say that I'm creating an object but I don't want it to be able to be accessed from all of the standard information, right? So let's go ahead and let's recreate that object here. Right, I'm gonna go ahead and instantiate that. Which as of right now probably means nothing to you, but that's just with standard objects, like with standard types like integers, floats, bools, all that stuff are built into the C# language themselves, so they don't need to be instantiated, while typed objects need to be instantiated, right? So I couldn't reference or use this vector v without instantiating it, right? If it's not instantiated and I haven't created the object itself or referenced another object itself, it'll return you null. And all null means is that it's blank, it's empty. There is nothing there. So if I now come back into here, normally I could just go into here and I could just say basic dot b, right? And then I could just do plus plus, right? That's what we did before, right? And I was referencing b and I was adding 1 to it. Pretty simple, right? But I can add something to the beginning of this that disallows other class objects to be able to touch this. I don't want anyone else to be able to edit this from another class or anything like that. This can only be touched and edited by itself, right? So I will do that by adding in this prefix called private, right? And now this statement is going to be invalid because by default all these objects are public, which means that any object can touch it, any object can use it. But if I put private in front of here, that means it can only be edited by itself. It can only be edited through functions of itself, right? And so with that being said, let's move on to functions, right? So a method is what they are called in C# and in programming languages in general. But all a method is a function, right? It is a list of a bunch of tasks for the computer to run through whenever I reference this specific object, right? So for instance, inside of Unity, whenever I have a game object, by default, this method runs, right? Or even, yeah, let's go with that, right? So I'm going to make a void and I'm going to call boot up, right? Now, just like variables, methods also have to be typed, right? I have to tell it what type of method it's going to be, and not so much what type of method it's going to be, but methods themselves can return you back information, right? I can call a method and then the method can do a bunch of calculations and then give you back something, right? Just like what happened here, right? I use this new signifier right here, this new identifier, and then I called the function called basics, and then it returned me an object. It returned me this new type object called basic. So inside of this boot up thing, notice here that I put void instead of any specific object, instead of boolean or something like that. And all void means that it returns nothing. It just runs and then it stops. Fairly simple. So here I can just do a++, right? Which that's pretty simple, but just by identifying it here, unlike these two methods, since these are ran by Unity itself, this method isn't going to do anything. It's just going to sit there. It has functionality, but it's never called, right? So I have to call it. I have to make it do stuff and call it to action and tell the computer, I need this to happen now. So all I do in order to do that is I just come into here and I just call boot up. And just like I said, it's the same thing that happened here in this statement, right? I wanted a basic object and I needed to create a new basic object, right? So I just re-referenced the function basics from our basic object, and then it ran a method that created a new object inside of the system and then returned me that object of information, right? So to make this even more interesting, I can take this and I can turn this into a bool, right? It's a boolean now. It returns true or false. So I can do a++ and then return true, right? So what that'll allow me to do now is I can still make this function. I can still call this function without adding anything else, and it'll still run through the information and return this information, but it returning information will be useless at that point because it's never using the information it's returned. But if I want it to return information and I want to use the information it returns, I can set another object equal to it. So I can say E is now equal to the boot up, right? Because E is a boolean and it's set to true, and then this up here returns true. So it would return the information whenever I called this, and then this would be set to whatever information that returns. Simple. Well, crank this up a little bit. Since these are also typed objects and they're contained inside of these class objects, that means that I can also add parameters such as private and things of that nature, right? So if I now set this to be to private boolean, now this can only be called within itself. Any other class that tries to call this function will return emptiness. And I'm not doing you guys justice by showing you this, so I'm going to go a little further into detail with this, right? So let's go into here and let's create a new class. Right, and then we're just gonna call this objects. And now let's open that up. Give it a second. Unity's a bit slow. There we go. Right. So, inside of here, I've already created objects and such of that nature, so I can create a basics object, right? Right, and I've instantiated it, meaning that the object is no longer null. But watch this. If I go into basic and I try and type in boot up, I get nothing. It's blank because it's private and it can only be accessed by its own class. Just like if I try and reference B, I get nothing. It's empty. I no longer can reference any of that information because it can only be edited by itself. And that's just the fundamentals of how that works. So that's the basics. That's pretty much everything that's going to be getting used for now inside of the Unity engine. If anything else comes up, I will explain it as I come along. This video is getting kind of long. Well, one more thing actually before I go is something called static. And it is another identifier. Just how you have private, you can also add static in front of this. And what static will allow you to do basically is reference that method or reference that variable without having an entire object, right? So if I set our string to be a public static string here, then I actually don't need this B object here anymore, right? I can just straight up call basics dot what's the object again? .s, yeah. And then I can set here and I can edit it and all that stuff, and I don't need to have an object to edit. There is a default object in the listing that is already set to that, right? So I can set that to be to whatever information, right? Haven't ran any code, haven't compiled anything, but you guys get the point of how everything fundamentally works here. That was a quick rundown of the way this system works. I hope you enjoyed the video, and I'll catch you guys later.